All right, Algebra peeps, this is it, our last module test. This is the practice test I'm doing, which will be a great guide for you to use as a study guide for the test. So when you take the practice test, try it on your own, find out where you struggle, then you can come back and look through my video and find those same type problems that you didn't understand and see how to work those. So we're going to do that together right here, the 908 Module 9 review and practice test. Let's get started. All right, Jane threw a basketball up in the air, and the following table represents the height in meters of the ball above the ground at t seconds. So here's our table. It says, which of the following is represented by the x-intercept of f of t? So let's think about this. Let's see what's going on here. At 2 seconds, it's a 10. At 4, it's a 15. At 6, it's a 10. At 8, it's a 0. So think about that. If we had the ground here and the ball, let's say at 0 seconds, 2, 4, 6, 8, right? So at 0 seconds, and then at 2 seconds, it's up here at 10 meters off the ground. And at 4 seconds, at 15, and then it's back down to 10, and then 8, it's a 0. So when it gets to 8 seconds, it's at 0. What's happening? The x-intercept, which would be right here, is when the ball touches the ground, right? That's when the ball touches the ground. The height is 0. That's the x-intercept. That'd be at 8 seconds, the ball will touch the ground. All right, don't make it harder than it is. It's not too bad if you just read it and think about what it's telling you. Okay, more graphs. A lot of graphs in this one. You have to understand what you're seeing, and that's a very important part of life, is understanding. There's so much information given to you in graphs and charts, in the news, in jobs, just everywhere. A biologist created the following graph to show the relationship between the temperature of the water, X, so it tells the temperature is the X, so this is temperature, in degrees Celsius, and the number of insect larvae, Y, in the water. So the larva. Let's see. What does the peak of the graph represent? Right here's the peak, right? Right there's the peak. At 5 seconds, we're at, looks like 450 larvae. So the peak represents the greatest number of larvae, right? The least number of larvae, the least number of larvae. The number of larvae is greatest at 5 degrees Celsius, or the number of larvae is greatest at 450 degrees Celsius. Which temperature? It said the temperature was X. So this is the temperatures down here. It's certainly not 450 degrees. It's 5 degrees Celsius. That's when there's the most larvae in the water. The number of larvae is greatest at 5 degrees. Next. For this graph, what should the domain be so that the function is at least 600? At least 600. Okay, so where is 600? 600 is right there. That's where 600 is. This function is at least 600 there. And so it's right there is when it hits 600. So anything before that, we don't care about. And right there is when it goes below. So anything of that, we don't care about. We care about this portion of the graph right there. When it goes from 600 there, 600 there. So what is that domain? Domain is the x's. Domain is all the possible x's for a function. So the domain when it's at least 600 would be from 0 to 20. X is less than or equal to from 0 between 20. 0 is less than or equal to x, which is less than or equal to 20. So x is between 0 and 20. And the underline means it includes it because it is 600 right there at 20 and at 0. It's at least. Now this is negative 10 to 30. Now that's the entire time it's above 0. This is everything greater than 0. And this is all real numbers. Now the graph itself has a domain of all real numbers. But when we limit it to when it's at least 600, then that shortens our domain just to that gap right there. So without this limitation, the domain would be from negative infinity to infinity. Number 4. A food package dropped from a helicopter and is modeled by the function f of x equals negative 12x squared plus 19,200. This shows the height, all right, this f of x, the height, which is the y, in feet of the food packet at different times, x in seconds. So the x is seconds. Seconds. And this is feet. Okay. Use the graph to determine the reasonable domain of f of x based on the context. So basically, if it's a drop from a helicopter, what's the reasonable domain? So from the moment it's dropped would be the highest point, right? So that's going to be where our domain would start in the context of this problem. Again, for the whole graph, the domain is all real numbers. But from the drop right there, and how far would our x's go? Well, it would only go until it hits the ground. It doesn't go plummeting deep into the earth. All right, this is a food packet that drops to the ground and it'll stop right there when the x is 40. So this will go from 0 on that end to 40 on this end, 0 to 40. All real right there. 0 is less than or equal to x, which is less than or equal to 40. So the x is between 0 and 40, inclusive. All right, here's the next problem. Draw a line now. The function below shows the number of car owners in thousands, f of t. So this is the number of car owners in a city in different years, t. So t is years. So the average rate of change of the number of cars from year 5 to year 8, because t is years, is how many thousand owners per year? Well, we have to know what it is in year 5 first. So f of 5 would be 0.25 times 5 squared. Notice the squared is with the t. It's not with the 0.25. We're not squaring the 0.25. We're just squaring the t, which is 5, minus 1.5 times 5 plus 2.5. So let's get our calculator and enter that in here. So 0.25 times 5 squared, all right, times 5 squared, minus 1.5 times 5, 1.5 times 5, plus 2.5. That is 1.25. So there's 1.25 in thousands, 1.25 thousand car owners in year 5. Now we need to know year 8. So f of 8, 0.25, 8 squared minus 1.5 times 8 plus 2.5. Let's see how many thousands of car owners there are in year 8. 0.25 times 8 squared minus 1.5 times 8 plus 2.5. 6.5. So there are 6.5 thousand car owners in year 8. So let's know the average rate of change. The average. Well, how much did it change? 6.5 minus 1.25. It changed 5.25. That was how much it changed. But it didn't do that in 1 year. It did that over 3 years, from year 5 to year 8. That's 3 years. So the average rate of change, we got to divide that by 3 to find out what the average. The average is per year. 5.25 divided by 3 is 1.75. 1.75 thousand owners per year. And it's a positive number because it went up. If it had gone down, we'd make it a negative 1.75, right? So average means per year or per whatever time period you're measuring there. Per year. All right, another graph. This shows the value of Edna's profits in dollars after T months. So T is months. Months. And this is profit, right? Okay. What's the closest approximate average? Oh, there's an average again. So it's going to be per month rate of change for Edna's profits from the 3rd month to the 9th month. Okay, so what was her profits in month 3? Looks like it's about right here, which somewhere between 41 and a quarter and 49 and a half. I don't know how well you can see those numbers, but so let's say it's going to be, we can give it a number of about 45-ish. It's going to be approximate. And then in month 9 would be about right here, which looks to be about negative 26. So first she was making $45, then she lost $26 in that period. So let's see, what is the difference? If we subtract negative 26 from 45, how much did it change? So it changed. If we're subtracting, that means you add them together because we're subtracting a negative. 1, carry the 1, 71. So $71 is how much it changed. And which way did it go up or go down? It went down. So she lost $71. That was the change from the 3rd month to the 9th month. But average, how many months we were looking at? 3rd to the 9th. 9 minus 3 is 6. So we're going to divide it by 6. So negative, and again, we were estimating, so it could be 70, it could be 72, it could be 68. It's just because it's hard to tell exactly what those numbers are, but it'll get close because there's a lot of difference in these right here too. So negative 71, negative 71, 71, there we go, divided by 6, 11.8, they have an 11.63. This is $6, $9, and these are positive. So those can't be, it's not positive. That's 69.75. That must be what they calculated it to be. They must have calculated 69.75. We were close. So obviously it's a negative 11.63 because that's the closest answer to what we estimated. Without them giving us exact numbers, we can only estimate about what they are. And we get a number that's very close to what they have. So that will be our answer. All right. Let's move on. Okay, we have two functions here, f of x and g of x. So f of x is right here, and g of x is a table. And it says, which statement best compares the maximum value of the two functions? Well, if we look at g of x, it starts at 0, goes up to 4, goes up to 8, goes back down to 4, goes back down to 0. So the maximum value is 8, right? The value of g of x. When the x is 2, it's at 8. So g of x is 8. But what is the maximum value of this? This is a quadratic. It has a negative in the front, so that means it will have a maximum because it goes down. So we know, what is that maximum? What is the vertex? How do we find what that x is? All right, we do it with negative b over 2a. Remember, that's when we have ax squared plus bx plus c as our quadratic function. So in ours, we have negative 4 is the a, and there is no b. We don't have an x term. We don't have an x term at all. We have a c that is 5, but b is 0. So negative 0 divided by 2 times negative 4, negative 8. 0 over negative 8 is just 0. So when the x is 0, this is at its maximum. What is that maximum? Well, 0 squared is 0, and negative 4 times that 0 is still 0, plus 5. So 5 is what it equals when the x is 0. That's the vertex. 0, 5 is the highest point of f of x. So g of x goes to 8. F of x only goes to 5. Let's see. It is 3 units lower for f of x because it's only at 5. Then g of x is at 8. Okay. Don't let them trick you. They have a higher and lower equal. All right. Okay, the following graph describes function 1. So here's the function 1. And here's function 2. Function 2 is this function right here. And then we'll know which, again, has a larger maximum. So this time, instead of a table, we have a graph. So we can look and see, well, the maximum is right there, which is at 1. So this maximum is 1. Okay, again, we can do the negative b over 2a to figure out what is the x. See, the x here was 4. When it was 4, the maximum was 1. Our x would be negative 2 over 2 times a. A is negative 1. So 2 times negative 1 is negative 2. Negative 2 divided by negative 2 is a 1. So when x is 1, this will be at its maximum. So f of 1 equals negative 1 squared plus 2 times 1 minus 15. So that equals negative 1 squared is 1. So negative 1 plus 2 times 1 is 2 minus 15. Negative 1 plus 2 is positive 1 minus 15. So the maximum for this one, its vertex is at 1, negative 14. It is way farther down on the graph. It never gets up. It never even gets up to 0. Negative 14 is the highest point on that. So function 1, we'll just put in the blank space. Function 1 has the larger maximum. Numero 9. Following graph shows f of x and g of x. So here's g of x, and some highlight g of x is up here at the top. F of x is right here. So the function g of x is obtained by adding what to f of x? How can we make f of x be the same as g of x? Well, this is 2, 4, 5. That is at 5. So if we add 5 to f of x, add 5 to 0, it goes up to 5. If we add 5 right here, f of x is at 4. If we add 5 to that, it goes up to 9, and it'll be right there where g of x is. If we add 5 to all the values of f of x, it will be exactly where g of x is. Add 5. Okay, what do we have here? The graph of f of x equals x squared is shifted 3 units to the right. So going to the right rather than going up or down to obtain g of x. So in that case, g of x would be over to the right. Which of the following equations best describes g of x? So to do that, would we add 3 inside the parentheses, x plus 3 squared? Would we have the x squared and just subtract 3? Now this one, we took x squared and we added 5. That's how we got from here to here. Because this is just a graph that we added 5. This might be 2x squared, or it might be something like that. It might be 4x squared, but we just added a 5 on the end, and that raises it straight up. So it can't be this one or this one, because adding it on the end would just move it up and down. It would not move it left or right. So to move right would be this one here. If we put minus 3, that shifts it to the right 3. Because to get back where we started, we'd have to subtract 3. 1, 2, 3. We subtract 3, we're right back where it was. So you got to go right, you got to subtract. This would actually shift it 3 to the left. That would go that way. All right, so that would go left. That would take our graph, move it left. That one right there. All right, let's move on. Identify the vertex for the graph of y equals 3x squared plus 12x plus 5. Okay, the vertex, again, we got to find negative b over 2a. So for this one, our a is 3, our b is 12, and our c is 5. A, b, c. All right, we got to identify our a, b, c. So negative b would be negative 12 over 2 times 3 is 6. 2a, 2 times 3, 6. So negative 12 divided by 6 is negative 2. So the vertex is going to be at negative 2 something. So we can cross out that one and that one. Those are positive 2. Got to be one of these. So now we go back to our original equation, and we will take this negative 2 and substitute it in. 3 times negative 2 squared, x squared, plus 12 times negative 2 plus 5. So negative 2 squared. What's negative 2 times negative 2? That's a positive 4. So 3 times positive 4 is 12. 12 times negative 2 is negative 24, and then plus 5. So 12 minus 24 is negative 12, and then we add 5, negative 7. So it equals negative 7. Well, that gives us that one right there. Negative 2, negative 7 is the vertex for that graph right there. The lowest point. Since this is positive, that would be the lowest point, the minimum. All right, this one says to solve. And it looks like there are whole number solutions, so we should be able to factor this. So this is a coefficient of 1. This has a coefficient of negative 12. So let's look at, for negative 12, how many ways can we get negative 12 by multiplying two numbers together? 1 and negative 12, negative 1 and positive 12, 2 and negative 6, negative 2 and positive 6, 3 and negative 4, and negative 3 and positive 4. If we multiply any of those pairs together, we'll get negative 12. Now, if we add them together, we're trying to find the one that equals a positive 4. Add those together, that's negative 11. Add those together, that's a positive 11. 2 minus 6 equals negative 4. When we add those, we're trying to get a positive 4. Negative 2 plus 6. Oh, that's the ones we want. So we can rewrite this now so we can factor it. X squared, and I'm going to use these numbers, minus 2x plus 6x minus 12 equals 0. So this is the same as that, but instead of 4x, I wrote negative 2x plus 6x because that will be the same as 4x. Now I can factor by grouping. What can I factor out of x squared and negative 2x? I can factor in x, so that leaves x minus 2. 6x and negative 12, the greatest common factor there is a 6. 6 out of 6x leaves x. 6 out of negative 12, negative 2. Now I've got two terms. I've got this term, x times x minus 2, or 6 times x minus 2. Both of those have x minus 2, so I'll factor that out. And what's left is x plus 6. So x minus 2 times x plus 6 equals 0 is exact same as this right here. It's just factored. So if multiplying those together gives us a 0, that means one of those has to be a 0. So if this is a 0, x minus 2 equals 0, that means x equals 2, because 2 minus 2 equals 0. Or could be that x plus 6 equals 0. So that would be when x is negative 6, right? Because you subtract 6 from both sides. X equals negative 6. So the solutions are 2 or negative 6. Oh, first one. That is our solutions, 2 or negative 6. All right. Write x squared minus 2x minus 3 equals 0 in the form x minus a squared equals b, where a and b are integers. So this is vertex form. It wants to take the standard form of a quadratic and put it into vertex form. So to do that, they want b on the other side, just the constant. We're going to move our constant to the other side. So we'll do x squared minus 2x. And we got to add 3 to both sides to move that. Right? So when we add 3, there's nothing left over here, and there's a 3 on the other side. Okay, so we're getting closer. We've got the b on the other side. Now we've got to make this into a perfect square, because that's x minus a times x minus a. So how do we make this a perfect square trinomial? We have to take this middle coefficient and divide it by 2. So negative 2 divided by 2 is negative 1. And then we take the negative 1 and we have to square it. What's negative 1 times negative 1? It's positive 1. So we'll add 1, and then we have to add 1 on the other side. Got to do it on both sides of the equal sign. So now x squared minus 2x plus 1 should factor, because we just made it a perfect square trinomial, to x minus 1 times x minus 1, and that equals 4, 3 plus 1. X minus 1 times x minus 1 is the same as x minus 1 squared equals 4. Oh, right there. That's the one we want. That's vertex form. Factoring this, completing the square so we can factor it into two perfect square binomials. Okay. 14. Okay, the function f of x equals negative x squared minus 5x plus 50 shows the relationship between the vertical distance of a diver from the pool's surface. So that's our y. Vertical is up and down. So this is our y in feet. And the horizontal distance, that's the x, of a diver from the diving board. So from the diving board to the pool, right, you got this pool here. The y would be how high he goes, and the x would be how far away from the pool he is. All right, so we've got how high and how far from the diving board. What is a 0 of f of x, and what does it represent? So we need to find a 0 of that. Okay, let's see if it factors. So I'm going to get one other sheets of paper, and we're going to need some extra paper to do this. -1 is the coefficient, and 50 is the coefficient. So -1 times 50 equals -50. So we need to find all the different ways that we can multiply and get -50, which is 1 times -50, or -1 times 50, or 2 times -25, or -2 times +25. Or we can go 5 times -10, -5 times +10. Is there anything else? That's all that comes to mind, that we can use whole numbers to multiply and get to -50. So let's see, if we add these together, do any of those get us to that -5x? Add those together, you get -49. Add these together, you get a +49, right? 2 plus a -25 is a -23. -2 and a +25 is a +23. 5 and a -10 is a -5. Hey, that's what we're looking for. So it's these factors right here, 5 and -10. So we can rewrite that as -x squared plus 5x minus 10x plus 50. And we want to find the solutions where it equals 0. Okay. So let's factor out the first one. We can factor out a -x, and leaves an x minus 5, because when we factor -x out of 5x, we get negative. And then we can factor a -10. And then that leaves x, and then -10 out of 50 is -5. So now from this term and this term, we got an x minus 5 in both of those. And this is -x minus 10. All right. So either x minus 5 equals 0, or -x minus 10 equals 0. So if this is true, add 5, x equals 5. If this is true, add 10, -x equals 10. So we divide by -1, x equals -10. So there's two solutions. One's at 5 feet away from the diving board. One's at -10. We discard the negative because the negative solution doesn't make sense because we're measuring distance. So x equals 5 is our solution. So this says, can't be this one or this one. The diver jumps in the pool at 5 feet per second. We don't have time in this at all. 5 feet away horizontally. Perfect. All right, let's do the next one here. All right, so function f of t equals 4t squared minus 8t plus 8 shows the height from the ground in meters of a roller coaster car at different times t. So t is time. And he wants to write this function in vertex form. A x minus h squared plus k, where a, h, and k are all integers. And then interpret the vertex. So let's write the equation, the function down here. First thing I see is we can factor out a 4 from everything to simplify this. All right, so that is the same thing as 4 times this expression here. We factor 4 out of all of that. So now we want to get it, and that's going to, our a comes out front there, you see. And now we need to get the perfect square trinomial in here. So let's make some room to do that. T squared minus 2t. I'm going to move this 2 over here because we're trying to create a perfect square trinomial. And we do that by taking this middle term, -2, and we got to cut it in half. Remember, we got to divide it by 2. So that equals -1. And then we need to square that. -1 times -1 equals 1. So we're going to add 1. And then we've got to subtract that 1 back off, or else we've changed the entire function if we don't subtract the 1 back. So that way we've done nothing. We added 1, subtracted 1. That puts us back where we started. Okay, so now this part of this is a perfect square trinomial because we just created that by completing the square. So we've got 4, and this is, I'm going to put a bracket around all of that, t minus 1, t minus 1, and plus 2 minus 1 is just plus 1. All right, so now we can simplify this as 4 t minus 1 squared plus 1. So if we want to interpret the vertex of that, 4 times t minus 1 squared, and then the 4. So if I multiply the 4 back in there, it'd be 4 times the t minus 1 squared, but I'm going to leave it this way. I'm not going to put it back together. And the 4 would also be times the 1. So this is this equation in vertex form. So what is the vertex? Interpret the vertex. So from the equation we came up with, it's not that one, it's not that one. It's one of these two. And so what is the vertex? This is a positive, so the graph would go up. So the vertex will be a minimum. And it says minimum. The minimum height of the roller coaster is 1 meter from the ground or 4 meters from the ground. Oh, so we have to figure out from that vertex, the vertex would be HK. So that would be 1, 4. So the minimum height of the roller coaster, 1 is time. At 1 second or whatever, it's 4 meters off the ground. 4 is the meters. So just remember, f of t is the meters, but the time, the x, the time is your x. This is time. That is not how high it is off the ground. 4 meters is the height of that off the ground. All right, let's move on. Okay, this has the steps to derive the quadratic formula shown below. So you can start with the ax squared plus bx plus c, and from that figure out the quadratic formula. This is in their lesson. You can see how you get from there to the quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. That's our quadratic formula. And here's the steps, except one of these steps is wrong. Which one is it? Well, let's see. What's the first thing they did? Is they subtracted c from both sides. Okay, that seems fine. It would disappear over here to show up over here. And then they divided everything by a. So they took ax squared plus bx equals negative c. And they said, okay, we're going to divide everything by a. When you divide everything by a, they said you get x squared over a plus ba x equals negative ca. Oh, I think we have a problem already. If you divide a by a, that's just 1. So this would go away. It would just be x squared as the first term. So we've got our problem right there. Step 3. We don't have to go any farther because we've already found what's a problem. If you divide ax squared by a, the a would cancel out and go away. It would just be 1x squared. And they still have the a there. So that's where they messed up. All right, we didn't have to go very far. Number 17. What is true about the solutions of a quadratic equation when the radicand of the quadratic formula is a positive number that's not square? So when we get down to this bottom of this, when you're right here, the radicand is this highlighted portion, right? Let me hide that. Everything under the radical, under the square root. That. What if that number underneath there is a positive number? It's not a perfect square. Let's say 21. That's not a perfect square, but it is a number you can find the square root of. It'd be a decimal. So in that case, Does that mean there's no real solutions? No, there's certainly a solution. If we worked it, you'd have your negative b out here. Maybe it's -2 plus or minus, and I'm just making this up, 4, right? That would have a solution. No real solutions. If that was a negative, there would be no solutions because we cannot take the square root of a negative number. Two identical rational solutions. Well, rational solutions would be a whole number, right? And two different rationals. That would be a whole number. We have two irrational solutions, which means we do have solutions, but they are not nice integers. They are something with some numbers that we cannot easily represent with a fraction or anything. Square root of 21 is not something we can represent with a fraction, so that makes it irrational. And so that is two irrational solutions. Now it says, what are the exact solutions of x squared minus 3x minus 5? Well, let's use that quadratic formula. So negative b plus or minus the square root b squared minus 4 times a times c all over 2a. So our a is 1, our b is -3, and our c is -5. Right? You just take the coefficient of x squared, the coefficient of the x, and then the constant. So our coefficient of x squared is 1. And let's substitute them into the quadratic formula. So negative b, -3 would be a positive. A negative. Plus or minus the square root of b squared. What's -3 squared? -3 times -3 is a positive 9. Minus 4 times 1 times c, which is -5. All over 2 times 1, which is just 2. Okay, so now that equals 3 plus or minus the square root of 9. Let's see, minus 4 times 1 is just -4, right? And so minus 4 times -5. So -4 times -5 is a positive. So this is a positive 20. So 9 plus 20 would be 29 over 2. And since 29 does not simplify into a nice integer, we can leave it as that. And that would be the exact solution. If we turn it into a decimal, we're going to have to round it. It would not be the exact solution anymore. So this is the exact solution. That is a negative out front. That's not the one we're looking for. 3 plus or minus 29 over 2. That looks like it right there. These have 11s. So that is our solution, the exact solutions for this quadratic equation right there. All right, what are the approximate solutions of 2x squared plus x equals 14, rounded to the nearest 100th? So we're going to do the same thing we did up here, but our a this time, we're going to have to set this equal to 0 to figure out what our a, b, and c is. If it's not set equal to 0, we'll have a problem. So 2x squared plus x, and then we'd have to subtract 14 from both sides to move it over. Minus 14 equals 0. So now our a is 2, our b is 1, and our c is -14. If we don't move that over first, we're going to look at that and say, oh, c is 14. No, it's not. It's -14 because we have to have it equal to 0 to use the quadratic formula. So a is 2, b is 1, c is 14. So negative b, -1, plus or minus the square root of b squared, 1 squared is 1, minus 4 times a, which is 2, times c, which is -14, over 2a, 2 times 2. Okay? So this is going to equal -1 plus or minus 1 minus, what's negative? What's 4 minus 4 times 2 is 8. 8 times -14. Let's see. 8 times -14. -112. So if I have 1 minus a -112, that means 1 plus 112, or 113 over 4. So there's two solutions here. One of them is -1 plus the square root of 113 divided by 4. And the other solution is -1 minus the square root of 113 divided by 4. And this wants to know the approximate solutions, which means they have converted those to decimals. So we shall do the same. -1 plus the square root of 113. Okay, that's this right here. It's that. And then when I divide it by 4, I'll divide it by 4. So 2.4 rounds up to 4.1. So it looks like it should be this one because this is a negative. Looks like it's this. I'm going to check this one, and then we'll double check this other one just to make sure that it matches the other answer here. So the other answer they have is -1 minus the square root of 113. It's that, and we divide that by 4. Negative 2.91. That worked. That was the other solution. All right, we got that. All right, getting close to the end. Not quite there. Sarah wants to hang a mirror in her room. The mirror and frame must have an area of 15 square feet. And the mirror is 3 feet long and 3 feet wide, 4 feet long. So what quadratic equation can be used to determine how thick to make the frame? Okay, she's trying to cover an area that's 15 square feet. So let's see, what is the area would be the length times the width. So what is this length? Well, this is x, right? So this is x, which means this over here is x. And this in the middle is how far from here to here? It's 4, right? 4. So this is 2x plus 4, because we start here, it's x wide, and then plus 4 more, and then plus another x. It means we have 2x plus 4 would be the length of this frame. And so the width of this frame from here to here would be x, and then up and down, this is 3. Tells us right over here. So this is 2x plus 3. So we know if we multiply length times width, 2x plus 4 times 2x plus 3, that'll give us the area, and we want the area to be 15. And we're trying to see which one of these equations this will be. So let's multiply this out. So we have to distribute, right? We're going to take this 2x and multiply it by both terms. And then we have to take, after that, we have to take the 4 and we have to multiply it by both terms to distribute. So 2x times 2x is 4x squared. 2x times 3 is 6x. 4 times 2x is plus 8x. And 4 times 3 is 12. And we still equal 15. Okay, so we got 4x squared. We can combine like terms. These are like terms. A 6x and an 8x can be combined to 14x plus 12 equals 15. We're almost there. We need to set it equal to 0. Set it equal to 0. So subtract 15 from both sides, which equals 4x squared plus 14x, 12 minus 15. There it is. 4x squared plus 14x minus 3. All right, a firecracker shoots up from a hill 160 feet high with an initial speed of 90 feet per second. So using this formula, approximately how long will it take the firecracker to hit the ground? So when will this hit the ground? So negative 16 t squared, that is gravity. That's the effect of gravity. Plus v is our velocity. We're starting at 90 feet per second. Plus an s is our starting. We started at 160 feet high. And it wants to know when we'll hit the ground, which means we need to know when does it equal 0? When is the height 0, right? Which means we need to solve this, which we can actually do, unless you think you can factor that. That might be kind of fun factoring, but I'm just going to use the quadratic formula. So A would be negative 16, B would be 90, and C would be 160. Since I have a calculator, so negative B is 90 plus or minus the square root of 90 squared. Let's go ahead and 90 squared, that's 8100 minus 4 times negative 16 times 160. All over 2 times a, negative 32. So let's simplify. Negative 90 plus or minus. Okay, let's simplify all of this underneath here. So if I have 8100 minus 4 times negative 16 times 160. Okay, that all simplifies to 18,340. The square root of 18,340 divided by negative 32. Erase that. I'm going to run out of space here. So that will simplify to negative 90 plus or minus. What is the square root of 18,340? Square root of 18,340 is 135.4. 135.4 divided by negative 32. So that's the two answers. One's when it's plus and one's when it's minus. So let's see what those equal with our calculator. So the first one is negative 90 plus 135.4, which is 45.4. And then I'm going to divide that by negative 32. And I get a negative answer. How long? So that is the negative solution. We're going to discard negative 1.4. We don't have a time, negative 0.4, negative 1.4. So now let's get the other solution. Negative 90 minus 135.4 is negative 225. And then divide that by negative, oops, not that, negative 32. And that leaves 7.04. So our answer is 7 seconds. 7 seconds. We discard the answer that does not make sense in the context of the problem, because there are two solutions to quadratic equations most of the time. Oftentimes, not most, but oftentimes there's two solutions. And so the solutions were negative 1.4 and 7, and we discard the negative because it doesn't make sense in the context of this problem. All right, number 22. Jacob kicks a soccer ball off the ground and in the air with an initial velocity of 33 feet per second. Using this formula, what's the maximum height that it reaches? So basically, what is the vertex? So if it's negative 16t squared, again, that's the effect of gravity, plus 33t plus, he kicked it off the ground. It started at 0. So our A is negative 16 and our B is 33. And I don't need the C because this is the vertex, which means the x is going to be negative b over 2a, which be negative 33 over 2 times negative 16, negative 32. So negative 33 divided by negative 32 equals what? Let's see. Negative 33 divided by negative 32, 1.03. So at 1.03 seconds, because that's the x, that's the t, the ball's going to reach its maximum height. So we need to go back to this equation and figure out at this time, negative 16 times 1.03 squared. I'm just putting that in for the time. Plus 33 times 1.03 plus 0. Don't have to add a 0. What is the height? 1.03 seconds after he kicks it. 16 times 1.03 squared. All right. That equals negative 16.97. And then to that, I'm going to add 33 times 1.03. Answer is 17. 17.0. Oh, there it is. 17.0. That's how high the ball goes. And it gets there in just a little over 1 second. It's 17 feet in the air. All right. Last couple. Based on the graph below, what is the solution to the equation f of x equals g of x? Okay, so f of x is right here. That's the straight line. G of x is the curved line, the parabola. What is the solution? There are two solutions, and they are where they meet. That would be a solution, and that would be a solution. So when those are equal to each other, what is the x value? Bring that straight down. It's a little bit more than 5. That one's just a little bit past the 2, negative 5. A little past the negative 5, a little past the 2. So the two solutions would be not negative 4 and 2, not negative 4 and 2 half, negative 5.1 and 2.1. That looks about right. And this is negative 5.1 and 1.5. No. So right there, that is the two solutions, those x's. All right, last problem. Based on the graph below, what is the total number of solutions to this equation, f of x equal g of x? How many solutions are there? How many times do those two graphs equal each other? One time. Right there, that's the only time those two graphs equal each other. All right, that is it. That is it. Make sure you can do well on the practice exam. If you can't do well on this, go back and see what you missed. You can look at this video again and take it again. This practice test is to help you make sure you're ready, that you're ready for the exam. So if you can do well on this, then when you get and start that Module 9 test, you'll feel a lot more comfortable and you'll do a lot better. So take advantage of this. Get everything done. This is an assignment. This is not counting a grade. Remember, practice tests are not counting a grade, but it is an assignment. So it needs to be done to be exempt for the final. So you want to earn those exemptions. So do work you can be proud of. I'll see you next time.